free to follow up with Rebecca with her contact information and the proceedings online. With that, we're going to move on to our next presentation from SCCF.
Okay, good morning. My name is Kevin Jones. I'm a research assistant with SCCF, and my talk is about nutrient monitoring in the Caloosahatchee estuary, which is a feature of our Recon water quality network that we'll be implementing soon. So why do we want to do continuous nutrient monitoring here? Well, there's a growing body of research indicating how important coastal nutrients are as a driver of harmful algae blooms, which here in Southwest Florida, of course, we have the Karenia brevis, red tide, and also cyanobacteria blooms in freshwater that can both be impacted by that. Right now, our nutrient data set for this area is pretty sparse. We're limited to field sampling, which is, limited by cost constraints and manpower, and having the ability to do continuous monitoring in the estuary would give us a much better and more thorough data set. So for a little background, what is Recon? It stands for River, Estuary, and Coastal Observing Network. It's a network of 7 remote water quality stations in the Caloosahatchee and the surrounding waters. Parts of it have been around since 2007, and we're currently using the Lobo instrument package from Seabird Electronics, which you can see in the picture there. So the parameters that we're currently measuring are temperature, salinity, depth, DO, FDOM, chlorophyll, and turbidity. A couple of our stations have weather stations for meteorological data, and 2 of them also have wave and current sensors. But as I said, we don't have any continuous nutrient monitoring yet. We just opportunistically take discrete samples whenever we are able to go out and maintain or replace the sensors. Next slide, please. So the reason why this network was set up, the Caloosahatchee since the late 19th century has been artificially connected to Lake Okeechobee. And currently the flow into the tidal portion of the river is managed by a series of locks and dams that are overseen by the U.S. Army Corps of Engineers. So data from Recon is compiled into a weekly memo to the Army Corps, which you can see our latest one on the right there, which they use in their management decisions about freshwater releases into the estuary. The main goal of this management is to prevent extreme high and low salinity events, which have happened frequently in the past and can have a pretty devastating impact on the estuary, especially on the oyster and tape grass habitats that we have in that area. So they are looking a lot at the salinity data that we're collecting, and then also at light attenuation, because we can have issues with high turbidity during the rainy season. Next slide. So challenges to keeping Recon running. In the about year and a half that I've worked here, we've actually had 2 boat strikes impact a couple of our sites. The picture you see on the right there, that used to be a channel marker piling in the Caloosahatchee just downstream from the Fort Myers Yacht Basin. So that was supporting one of our Recon sites. And then just recently, we also had another piling in San Carlos Bay taken out, and that both of those incidents took a couple of our sites offline for quite a while. And then the other constant challenge is fouling. Here in Southwest Florida and inshore waters especially, we're in a really high biofouling area. So on the left there, you can see the shiny copper and blue Lobo package that's ready to go into the water. And then to the right of that, that's what one of those Lobo arrays looks like after about a year in the field. So pretty heavy fouling. And next slide, please. So these instruments, some of them are optical sensors. So biofouling can have a significant impact on those. This is chlorophyll and turbidity data from the Fort Myers, Beautiful Island site, which is our furthest upstream Recon site in the estuary. So April 23rd there, where that big jump in both graphs is, that's the most recent time that we cleaned this sensor. So, turbidity, you can see, drops from about 120 NTUs down to almost nothing, and chlorophyll jumps in the opposite direction up to about 10 micrograms per liter. So this is a result of sediment and biofilm building up on the lenses of the optical sensors. And depending on the time of year and amount of rainfall we're getting, this kind of fouling can happen in as little as a month or as long as a couple months during the dry season. So that's Recon as it is today, and now I want to get into the nutrient sensors that we're going to be deploying. And I should add that right now, implementation of these new sensors has been pretty much halted by the COVID situation, but we are hoping to get these out in the field as soon as possible. So this is a map of all of our Recon sensors, and then I've highlighted the Beautiful Island site at the upper end of the estuary. We'll be getting a Hydrocycle phosphate sensor and a SUNA V2, which is a nitrate sensor. And then Shell Point at the lower, or at the mouth of the river, is going to be getting a WIS, which is another nitrogen sensor. So we'll have nitrogen data from both the upper and lower end of the estuary. So it should be interesting to be able to compare those two data sets. And the WIS at Shell Point actually it was deployed for about 6 weeks at the end of the dry season before we had to close our lab down. But we were not able to collect any usable data from it. And we suspect that the nitrogen concentrations may have just been below the detection threshold for that whole period. Next slide. So to get into what these sensors are, the Hydrocycle, this is made by Seabird Instruments. It is a wet chemistry sensor, reports dissolved phosphate, and uses the same molybdate colorimetric reaction that is often used in benchtop phosphate analysis. Interesting thing about this sensor is that it uses pre-made reagent canisters that you have to buy from Seabird. So that does simplify the deployment of the sensor a bit, but it also does add to the operating costs. Those canisters are advertised to be stable for up to 5 months in the field. So this could potentially be useful for long field deployments with hopefully pretty minimal maintenance. Next slide. So then we will be implementing 2 different nitrogen sensors. The first is the WIS, which is made by Sistea. This is also a wet chemistry sensor. Unlike the Hydrocycle, this one has refillable reagent canisters. So we'll be able to make our own reagents in the lab for refilling this instrument. There are a number of different configurations available. Ours reports NOx, so just the combination of dissolved nitrate and nitrite. And then the SUNA V2 from Seabird is a completely different instrument. This is a UV spectrometer. So it's an optical instrument, no reagents to refill, so that does simplify deployment a bit. But like our other optical instruments, this one could be impacted by biofouling. So, time will tell how big of an issue that'll be for us. Also slightly different in that it reports dissolved nitrate only. And then another difference between these 2 types of sensors is the wet chemistry version, as you can see, gives us a slightly lower method detection limit, which could be important during the dry season when nitrate concentrations seem to be pretty low. So we'll go to the last slide. And I think I'm almost out of time, but this is just to give you a preview of what we're hoping to see from this data set. These are the few discrete samples that we've been able to analyze from Beautiful Island and Fort Myers, which are 2 of our Recon sites in the river. So not a whole lot to go off of because of the small data set, but one interesting point is for both nutrients, they're higher at Beautiful Island at the upper end of the estuary than they are at the Fort Myers site, sort of the midway point of the estuary. So I think that's about all the time I have, so I'll move on to questions now.
Great, thank you, Kevin. So for those of you online, go ahead to menti.com and use the code 639808 to start putting your questions in for Kevin to answer. Go ahead, Kevin.
Okay, so do the optical sensors have wipers? Yes, they do, and over the years, Seabird has definitely improved their wiper designs. So we've noticed on our newer Seabird instruments, the newer types of wipers that they have seem to be a bit better. But regardless, you do still have to get out there and manually clean some of that biofilm off of there occasionally. Costs associated with the sensors, I'm actually not sure. That's I don't really do any of the purchasing for these things. I know all of them are quite expensive, but I can't comment on the exact costs. So the Wiz, our version of it just gives us NOx. I'm not sure if they have one for total nitrogen because I know that's a more complicated reaction. There's a digestion process that you have to do. But I do know that the Wiz can be configured for NOx or just nitrate or nitrite, or they also make a orthophosphate version of it. So why the different sensors? So the Wiz, we're actually part of a pilot program that's being organized by LumCon, a lab in Louisiana. That's a Systea and the Wiz are a fairly new company, so they're just sort of testing out this sensor. Everything's moving here. Flow into... Sorry, the questions keep moving and disappearing here. Okay, so flow info, we do have some. I believe that mostly comes from the Water Management District, but we do have some flow data from them that we can look at to compare with our nutrient data set. And then inorganic species only. That's a good point, and we do have the capability to run total phosphorus and total nitrogen from our benchtop nutrient analyzer, but as far as I know, there aren't any continuous monitoring sensors that can look at organic species, or at least we don't have those yet. And yes, we will be taking reference samples to compare with the results from our new continuous monitoring instruments. We've already been taking grab samples whenever we go out to replace or maintain the sensors. So we will keep doing that. Salinity interference with chlorophyll fluorescence. I believe the Seabird instruments have a correction factor that takes that into account, since we're monitoring salinity and chlorophyll on the same instrument. I'm not exactly sure how that works, but I think their instruments do take salinity into account in the chlorophyll values that they report. All right. Oh, there's some more questions. Okay, so how do changes in watercolor affect the optical sensors? That's an interesting question because I know with previous versions of Seabird's nitrate sensor, there has been interference from CDOM. I think the SUNA V2 is meant to correct for that, since we will be monitoring CDOM and the Seabird instruments are all reporting to the same data logger. So hopefully we won't have as many issues with that. So that's all the time we have, and thanks very much for attending.
Thank you, Kevin. We really